In this film, I will continue my example in Codesys on SFC programming, where I will focus on the different types of qualifiers, and I will also show how to make actions and transitions as subprograms. I will start with a reminder of the different types of qualifiers that we have for the SFC program. In the previous film, I used the non-stored N, where the action is active while the program is in that step. Now I will try the set and reset, the time delay, and an example of the pulse. For the time delay, and also for time limited or different versions of them, we need to have a time as well, which is written within the box for the qualifier. For example, D and a space, T hashtag, and the time. I will try those in Codesys. Here is my Codesys program from before. I have removed the parallel branch. We still have the alternative branch. And here is the N qualifier for motor back, for example. And just as a reminder, I will make button 2 true and motor back will be true within the back step. But as soon as we go to step 0 here and the cylinder is activated, this motor back will be false. Bam. Now motor back is false. And we are waiting for the 10 seconds here in step 0. I will log out and I will try the qualifier S. If I use S for set, I have to make a reset somewhere within this program. I cannot make that reset in another program. It has to be made in this program. If I want motor back to run while the cylinder is moving as well, maybe not because it has hit sensor back, but we can try it. Then I can make a reset of motor back here. I right click, insert action association, and change the qualifier to R and motor back. When I log in, my program will be in this step, waiting for button 1 and sensor front. If I make them true, we will have a program running here, and I would like to test this branch. I will change button 3, which means that we can test things separately. I declare it as a new variable. I can log in with online change, then I was in this step, waiting for button 3. I will make button 3 true. And we are back in the init step. Now if I make button 2 true, sensor back is still true, I will just move through this step, but during that time, the program has time to set motor back. I will make button 3 false and button 2 true. We jumped immediately here because both this transition and this transition were true, and we jumped into here, waited for the 10 seconds, and now we're waiting. And motor back is reset. I can try a delay as well here. If I want another cylinder to go out after 10 seconds, then I can put it in this step. And in order to see what will happen, I can increase the time that we are in this step to 20 seconds. And I will add an action association here for second cylinder. And I use D and the delay. Space T hashtag 10 minutes. And the name of my new cylinder. I have to declare it as a local variable. Now I don't really see what's in this box here. To increase the size of the box, I can go to Tools, Options, SFC Editor, and Qualifier Width 4. Okay, and now I can see what's written in the box here. I will try this as well. I will log in with download this time, and I will start in the init step. In the init step, nothing is running. I have to start the program, and we're waiting for button 2. Now we're waiting for sensor back. When sensor back becomes true, it will be in step 0. Motor back will continue to be true. Cylinder will immediately be true. And then after 10 seconds, SIL2 will be true. And after 10 more seconds, we will leave the step and both will become false. Now cylinder is true. and we're waiting for the 10 seconds. Cylinder 2 became true, and when we come to 20 seconds we will leave the step and both will become false. Now, motor back also became false because we have a reset on that here. I log out. Now I will show how to make a bit more complicated action. I will right click on my SFC program and choose Add Object, Action. I will make a better name for my action. It's a good idea to call it action, because then we know that it's not a variable. I will call my action count, because I want to count something. And here I simply want to add 1 to a variable. I make an add block, and I have a variable. It is not declared. I will declare it as an int. It is not declared here. It is declared here in my SFC program. This is a subprogram of my SFC program, and they share the same variable list. I will add 1 to variable. Here I need assignment. Variable. Now this action count is here in my tree. I would like to do this when I am in this step. Insert action association, and now I can write the name of my action. It should not be declared as a variable. It's a program, should not be in the variable list. If they have the same name, Codesys will use the variable. If I use the n, I will add 1 to variable as long as I'm in this step. I probably just want to do that once. Then I can try the p qualifier. However, p makes the program count twice. I will show this. I log in with download to start an init. I will start, and now I can go through button 1 sensor front if I want to, and make them both true to jump into this step. And we can look at the value of variable, and it is 2. I will activate button 3 again, and at the same time deactivate sensor front, and here it's 2. Which means that I activated this action twice when we entered the step. We'll go through this again, make sensor front true, and button 1 false. Now this one is poor. Using the p made us count twice here. Of course I can compensate for that by dividing variable by 2, or I can use a trig. I will change this to a block with enable. Now I can have a trigger here. A trig, and I have to declare it. And I will use true when I come into the step. Now I set the rtrig true when I enter this step. I can use n here now. But that means that I have to make the rtrig false in another step. I make a new action, a reset action, where I use the same rtrig block, and I give it the same name, because then it is the same block, and I give it the signal false. This action I can use in another step. I will always go back to init after this step, which means that I can reset it here. And I use action reset. I will log in and try this. I log in with download to have variable restart at 0. And I start here. Now my action reset is activated. And I will go through button 1 sensor front. And I'm here, and my variable has counted up to 1. I will activate button 3 as well. And now my program will just run through here a couple of times until I make button 1 false. And we can see that in that short amount of time, managed to activate this 16 times. I will make button 3 false again, and button 1 true. And now we have got the 17th time. I release button 1 and press button 3, still 17. The reason why I had to activate and deactivate the rtrig is that I activated it once while in this step. Then in order to deactivate it, I need to do that in another step. As long as we are not here waiting for another signal to happen, then I can activate and reactivate it in the same step. I can make transitions as subprograms as well. If I want to have something more complicated than button 2 here, I can make a transition. Transition back is not a program yet. I have not made the program, which means that Codesys believes that this will be a bool variable. It will not be a bool variable. I just haven't made my program yet. Do not declare it. Here I will add object transition and I will call it transition back. Here I can make a program checking if something is true. For example, I would like to go into that transition if variable is greater than 5 and button 2 is pressed. I do not have to have an assignment here, but it's a good idea to have it. It's easier for Codesys to recognize what's happening if I do. We'll drag it in here and I will call it the same name as my transition back. Codesys allows me to make another network here, but that is not the standard. In the standard, we will have only one network for a transition, and the name of the transition should be on the only Boolean output from that network. The transition is only there for checking if something is true or false, and in this case, this expression. I'll try this. I will log in with download because variable was already 17 and I will reset it. Now, if button 1 is pressed, we will go here regardless of what variable is. But if it's not pressed and variable is more than 5 and button 2 is pressed, then we'll go here. I will try with button 2 first just to check. Nothing happens. I will have to go through button 1 and sensor front. I will release button 1 and hit button 3. Now variable is 1 and I will continue until variable is 5. And I will release button 2 while I'm doing that. Now variable is 5, still not more than 5. I will make this once more. Button 3 is true, button 1 is false. And I will make button 1 true, button 3 false. And I'm here, variable is 6, which means that I might be able to go into here if button 2 is true. I will make button 1 false and button 3 true. And now I'm in it. I'm waiting for button 1 or for button 2 because now variable is greater than 5. If I make both button 1 and button 2 true at this time, I will continue to go through this step. I will make button 3 false first, button 1 and button 2, and I moved through this one. We can see that both transitions are true here. If I continue to have button 2 true and release button 1, then the program will go here. Button 3 true, and my program immediately went here. Now cylinder 2 will be true, and we're waiting in this step. We can make transitions and actions as subprograms to the SFC program. When we do that, be careful to just have one network for your transition. The transition should not do anything. It should just check a condition. In my action, I'm doing something, and here I should not have any conditions. Use the conditions to move between the steps as the transition, and use actions for doing something in the program.